so this is 121.15. Okay, so when we have something that forms multiple kinds of cations, so the metals, we have Cu1 plus, which is the copper 1 ion. Well, we also have Cu2 plus, which is the copper 2 ion. Okay? They obviously have different charges, and that means they form different ratios in ionic compounds. So when we're doing this, we can't just say, let's do that. That's a copper oxide, but the question is, which copper oxide is it? So there are two skills that you're going to build here. One, me giving you the name of a compound and you writing a formula for it. The other one, me giving you the name of a compound, me giving you the formula for a compound and you naming it. Okay, so let's practice. Let's see, I give you a compound composed of copper 1 ions plus oxide ions. Okay. This compound is called copper 1 oxide. Okay, great, easy. So our first step whenever we're going from a name to a formula is to write the ions. What's the formula, what's the copper 1 ion? Cu, Grant's tomb, what's the charge on a copper 1 ion? 1. Cu 1 plus. What's the charge on an oxygen ion, an oxide ion? 2 minus, right. Okay, so our second step, we make room for our crisscross. We're going to carry those down. We get a 2 and a 1. And then we look to see if we can simplify. Can we? Yeah, we can get rid of the 1. Cu2O is the formula for copper 1 oxide. Easy, right? Very simple. So let's do a couple of others. Let's say I give you a formula, or I tell you that I'm giving you copper 2 oxide. Okay, first step, writing your ions. What's a copper 2 ion? Cu2 plus. What's the oxide ion? O2 minus. Second step, doing your crisscross. So we get 2 and 2. Third step, can we simplify that? Yeah. That will be just CuO. Okay. Let's do some more interesting. These seem fairly easy, right? If you can do the straight up binary ionic compounds, you can do these. This is the easier part of this stock system. All right. What if I give you, let's get into some more interesting, more fun ones. Let's get into the weird, wild. Okay. Okay. We'll do tin. Oh no, that's boring. I was just hearing about scandium on the radio this morning. So if we have scandium 3 oxide. Now, are you noticing a pattern here? Yeah. These transition metals tend to form compounds with oxygen. They tend to form oxides. You know, you're all familiar with iron oxide. It's rust. And, you know, these readily form oxide. So we do a lot of oxide compounds here. Okay, so scandium-3 oxide. What would be the symbol for scandium-3? Ion Bible. It's Sc, 3+. And oxide is O, 2-. It's our first step. For our second step, we'll want to do our crisscross. And for our third step, simplify if possible. Okay, Sc2O3. That would be scandium-3 oxide. Actually, I'm not sure how many other cations scandium makes, but okay. You want to do one more of these, and then we'll move on to flipping it on its head? Okay. Vanadium. There's another weird one. Oh, actually, you know what? We will do nickel 4 sulfide. Nickel 4 sulfide. Okay, so that would be, first of all, start off with writing our ions. Nickel 4 is Ni 4+. Sulfide is S2-. So when we do our crisscross, can we simplify this? NiS2. Okay. Straightforward. When you are handed a formula for something that you know is a transition metal, and you have to name it, you must specify which cation you're talking about. So if I tell you that I have FeO, well, let me not start with that one. If I tell you I have Fe2O3, it's an iron oxide, right? Okay. This is a two-step process, and yet this is the one that most people will trip over their feet on. I'm just going to warn you of that. This is the one that is more of a pitfall for folks. So what I do to keep myself straight is I actually kind of start with the second step to remind myself where I'm going with this. I write this, iron something oxide. Because if on a test you tell me that that's iron oxide, it's wrong. I know it's an iron oxide. Which one is it? So knowing that, I'm going to do sort of a reverse crisscross, and I'm going to reconstruct my ions. So we know that the iron is going to have a positive ion. It's a transition metal. They always do. We know that the oxygen is going to have a negative ion. Oxygen always does. So that would give us, if we reverse our crisscross, it would give us an Fe3 plus O2 minus. Is 2 minus the ion that oxygen typically forms? Yeah. So that seems right. So this would be iron 3 oxide. Not so bad, right? We're going to get into the harder cases, and we're going to, when we scramble it all up, it gets to be lots of fun. Okay, let's do another case. Let's say I give you CO, Cl2. Okay. So again, I'm going to start with my end product. What's CO? Cobalt, the pretty blue colorant. So this is cobalt something chloride. We don't know which cobalt ion this is, though. So we're going to do our reverse crisscross. We know cobalt will form what kind of ion? Positive or negative? Positive. It's a metal, it's happy. Chloride will be negative. That would give us a cobalt 2 plus and a chloride 1 minus. Is 1 minus the ion that chloride typically forms? Yeah. So this appears then to be cobalt 2 chloride. Okay. Now we're done with the easy ones. Let's do some more interesting ones. So what if I gave you PbO? What's Pb? I don't want any lead in my peanut butter sandwich. That's gross. That's a mnemonic for remembering it. You'll thank me at some point or not. Okay, so we know if we start with that second step, we know that this is lead something oxide, right? So far so good? Okay. We're going to do our reverse crisscross. We know that lead, because it's the metallic ion, it's going to be positive. Oxygen's going to be negative. If we do our reverse crisscross, we get 1 and 1. Is oxygen 1 minus the typical oxide ion? So what happened here? It's been simplified. So knowing that this has to be a 2 minus, we're going to multiply this by 2. Okay? So this would be lead 2 oxide. So if I were to give you VO2, it's also something that's used in sports medicine as it's something like, you know, volume of oxygen moved through the body. I don't know, Lance Armstrong probably knows his VO2, but I don't. All right, so if we start with our second step first, V is vanadium. So this is vanadium something oxide. And if we do the reverse crisscross, knowing vanadium will be a positive ion, oxygen will be negative. We get V2 plus 1O1 minus. Is that correct? No, because oxygen forms a 2 plus, so we know this has been simplified. We know this has got to be 2 minus. We're going to multiply everything by 2, so that's got to be 4 plus. So this is vanadium 4 oxide. These aren't difficult. There are just potential pitfalls. And the biggest thing is when you're doing that sort of reverse crisscross, the fact that you're very often seeing things that have been simplified. So you have to just remember, you know, your keystones. Oxygen's always going to be a 2 minus in these compounds. The halogens are always going to be a 1 minus. If you're coming up with a halogen that's not 1 minus or an oxygen that's not 2 minus, something was simplified. Okay? For practice, page 209 has some lovely practice problems of this sort on it. I also added 2 problems to the homework, number 8 and number 16. So you've got the rest of the time to work on those. When you walk in the door tomorrow, there will be an online FIP quiz, and that's it.